In this lesson, we will learn encoding schemes, ASCII, ISCII, and Unicode, with focus on UTF-8 and UTF-32. Encoding allows computers to represent text using standard codes. We will learn what encoding means, why standards are needed, how ASCII and ISCII work, and why Unicode was developed. A computer understands only binary values, 0 and 1. When a keyboard key is pressed, the character is mapped to a unique code, and that code is converted into binary. This process of representing data using a specific code is called encoding. Standard encoding schemes are important because computers must agree on the code used for each character. Before common standards, different representations made communication difficult. A standard lets the same character be recognized consistently. ASCII stands for American Standard Code for Information Interchange. It was developed to standardize character representation and provide a common way for computers to represent keyboard characters. Initially, ASCII used 7 bits. 7 bits can produce 2 to the power 7 or 128 different codes. ASCII can represent the character set of the English language. NCERT uses the word data as an ASCII example. D has code 68, A has 65, T has 84, and A again has 65. Each decimal code is then written as a 7-bit binary value for the computer. ASCII solved the problem of standardizing English characters, but computers also need characters from many other languages. This created the need for encoding schemes that could support Indian and other world languages. ISCII stands for Indian Script Code for Information Interchange. It was developed in India in the mid-1980s to support Indian languages on computers. ISCII uses 8 bits, so it can represent 256 codes. ISCII keeps all 128 ASCII codes and uses additional code space for Indian language characters. NCERT also notes that codes in the upper region from 160 to 255 are assigned for language aksharas. Many language-specific encoding schemes could not communicate properly with one another because each represented characters differently. Unicode was developed to provide one standard for characters from written languages around the world. Unicode gives every character a unique number. This number is independent of the device, operating system, or software application. Unicode is also a superset of ASCII, and the lower ASCII values represent the same characters. NCERT lists UTF-8, UTF-16, and UTF-32 as commonly used Unicode encodings. In this lesson, our focus is UTF-8 and UTF-32. Both belong to Unicode. NCERT also asks us to think about why UTF-32 takes more space than UTF-8 or UTF-16. Unicode can represent Indian scripts such as Devanagari. NCERT gives the example of the Hindi character A. It is mapped to hexadecimal 0905, which can then be represented in binary for computer processing. Remember the difference. ASCII is a 7-bit code for the English character set. ISCII is an 8-bit code developed for Indian languages. Unicode provides unique character numbers for written languages across devices and systems. Let us recap. Encoding maps text into standard codes. ASCII supports English characters. ISCII supports Indian scripts. Unicode provides a common worldwide character standard, and UTF-8 and UTF-32 are Unicode encodings. Encoded text is finally converted to binary for processing. Thank you for watching this video. For more computer science revision, visit www.tuitionharbour.com or email at hello@tuitionharbour.co.uk.